In the following videos, we're going to discuss completing the square. And completing the square is of uh, a method of doing some algebra in order to manipulate an equation or an expression to look like what we want it to look like. So here's why we might complete the square. For example, we already know how to graph x minus 3 squared plus y plus 5 squared equals 4. We know that x minus h squared plus y minus k squared equals r squared is something that we've just practiced that for a while. So we know that the center is at 3, -5, and the radius is 2 because 4 equals r squared means that the radius is 2. That's something we already know. However, if we're given a problem that looks something like this, we do not know how to graph that in its current state. It looks kind of intimidating, as a matter of fact. So our objective is going to be to make sure that we know how to complete the square so that when we complete the square, it can look like x minus h squared plus y minus k squared equals r squared. So that's our objective. The first thing we're going to do in the process to complete the square is make sure that we gather all of the x terms together. And then we're going to add something to that. And we'll talk about that in a second. Then we want to gather all the y terms together. And we're going to add something to that. And then we want it to equal to, well, this 30. We're going to subtract it from both sides. So now we have minus 30 on the right side. Now, one thing that's really important is notice that I'm adding a couple of things. Well, if I add them to the left side of an equation, I'm going to have to add them to the right side of the equation as well, or else it doesn't stay balanced. Okay, so now let's take a look at what we might want to add to these two things. I want something to look like x minus h squared. So in this case, I want to somehow convert x squared minus 6x plus some number into x minus something or x plus something squared. So that's my objective. The way that I'm going to do that is I'm going to take -6, which is this middle term. I'm going to divide it by 2. So that gets me -3. That number will go inside the parentheses. So now I have x minus 3 squared. Then I want to take what's left, so -3, and I want to square that. That gets me 9. That is the number that I add on that blank that I just put. Remember, if I add it to one side of the equation, I have to add it to the other side of the equation. So I have x squared minus 6x plus 9. If I go back to algebra and I factor x squared minus 6x plus 9, and I put two parentheses, I would put x and x, and then I'd figure out which two numbers multiply to 9 and add to -6. It would be -3 and -3, which, if I rewrote it, notice that anything multiplied by itself is the same thing as saying it's squared. So our objective is to find the number, which in this case was 9, that if I put it in that spot, I end up with a perfect square. That is our objective. Now we're going to do the same thing for the y's. I'm going to take the middle term, which is 10. I'm going to do 10 divided by 2. That gets me 5. That is the number that I'm going to put in the parentheses when I square the equation. So I have y plus 5 squared. Then I take that 5 and I square it, and I get 25. 25 is what I will put on the blank right next to the y squared plus 10y. Remember, if I add it to one side, I also have to add it to the other side. So let's just recap why we're doing what we're doing. I want to put a 25 in that spot because y squared plus 10y plus 25, if I factored that back in algebra class, I would have y and y. Then I need two numbers that multiply to 25 and add to 10. That's plus 5 and plus 5. Notice that if I have the exact same thing multiplied by itself, I can rewrite it as y plus 5 squared. Then I just add all of these things on the right side of the equation together. So negative 30 plus 9 plus 25 ends up equaling 4. So I have now completed the square a couple times, and I have turned something that looked really intimidating, x squared minus 6x plus y squared plus 10y plus 30 equals 0, into something that we actually want to look at when we are solving an equation or graphing a circle. So my center is at 3, negative 5, and my radius in this problem is 2. Now what's pretty crazy is we knew how to graph this if I gave it to you in its graphable form. But now we know how to graph it even if I give it to you in what we call general form. So if we're looking at this and I give you an equation that looks a little goofy, we can complete the square, and now I can graph circles even if they're not given to me in a relatively nice form.